Okay, you should have already done the warm-up. You were supposed to multiply all of these by the number outside, the term outside. So a times 3a is 3a squared, because you have an a here and an a here. And then a times 7 is a positive 7a. We've done this before already. Okay, negative 2m times m squared is negative 2m to the third power, because it's 1 here and 2 here. Negative 2 times 6 is a negative 12, and you have 2 m's, so that's m squared. And then negative 2 times negative 1 is a positive 2, and you have 1m here, 0 here. Okay? And then the last one, 4x cubed y times x squared. 4 times 1 is 4. How many x's do you have? 5. How many y's do you have? 1. And then 4 times negative 2 is a negative 8. How many x's do you have? Just 3. And how many y's do you have? 2. Okay? So what we're going to do today is we're going to work backwards. Backwards. That means you're going to start with this, and you're going to figure out what do these two have in common. And you're going to take it out. Okay, so both of these have an a in common. This one has 2 and this one has 1, so they have 1 in common. That's why there's 1 outside. Okay? Problem number 2. All of this has a negative 2 in common and an m in common. They all at least have 1 m. That's why on the outside you have a negative 2 and an m. Okay? And then the last one, they all have a 4 in common, right? Both of these have a 4 in common. And they have at least 3 x's in common and at least 1 y in common. That's why you have a 4 on the outside with 3 x's and a y. Okay? So we're going to take out what they have in common. Lo que tienen en común, lo vamos a sacar. So simplest form would be, like an example would be 4x plus 2. That's simplest form. Factored form is when you take stuff out. So what do these two have in common? A 2, right? So I can take out a 2, and what do I have left over? If I divide this by 2, it's a 2x. And if I divide this by 2, it's a 1. Okay? So it's like we're taking it out and we're dividing it. Now, just like I told you before, polynomials that cannot be factored are called prime. So if I cannot take anything out, they don't have anything in common other than a 1, then it's a prime polynomial, and it cannot be factored. Okay? So the steps that we're going to do is 1, check the coefficients. That means the big numbers for greatest common factors. That means what do they have in common? What can both of them be divided by? I'm going to give you, Desmos can do this for you. Okay, so now you don't even have to worry about, well, what can all of this be divided by, the greatest common factor. I'm going to show you right now how to do it in Desmos. Okay, and then you also have to look at the variables. So how many do they have in common? And take that out. Okay? Then at the end, you're going to divide everything by the greatest common factor. And then we're going to take out however many x's or y's or variables they have in common and see what they have left over. Okay, so we're going to do a few examples together. We'll do a few examples with you. Let's do problem number 1. Okay? I need to find the greatest common factor for 3 and 12. And some of you already know it, okay? But those of you who don't, greatest common factor, we're going to put that in the calculator with parentheses, 3, 12, close parentheses, and that will give you the greatest common factor. Even though some of you already know that it's 3, right? Both of these numbers can be divided by 3. Therefore, the greatest common factor is 3. But let's type it in Desmos just to make sure that it does work. Everybody in Desmos is typing the letters GCF, greatest common factor, parentheses, and the numbers that you want to find that are greatest common factors. So 3, 12, close parentheses. Okay? Everybody type it in decimals right now. You can pause the video if you need time to do that. So they both have a 3 in common, right? That means this problem, they have a 3 in common. So I'm going to take the 3 out. And then what do I have left over? So we start dividing. What's 3x divided by 3? 1x. What's 12 divided by 3? Positive 4. And you're done. You factored it. Okay? Problem number 3. Problem number 3. 8 and 36. So I need to find the greatest common factor of 8 and 36. And you can type, you don't need to retype everything. Just change the numbers inside to 8 and 36 in decimals. Change these numbers. 8, 36. So they both have a 4 in common. That's my greatest common factor. So we're going to take out a 4. Okay, and what do you have left over? Well, also tell me, do they have a letter in common? No, they don't have a letter in common, so I don't take out a letter, a variable. So now let's divide. 8m divided by 4, 2m. 36 divided by 4, positive 9n. Okay? Let's go to the back page, because you guys are going to do 2 and 4 in just a little bit. Let's go to the back page. Problem number 6. Greatest common factor of 4 and 24. Greatest common factor of 4 and 24. Change the numbers in decimals. Four, 24. So my greatest common factor is 4, so I'm going to take out a 4. So I'm going to take out a 4 from this one. Do they have a letter in common? Yes. How many? They have one y in common, so I'm going to take out a y. And then you start dividing. What's 4 divided by 4? 1. How many y's do I have left? 1. Because y times y is y squared. What's negative 24 divided by 4? Negative 6. And if I take out a y, how many y's do I have left over? None, right? So this is my factored form. Let's do problem 27. What do those two have in common? Greatest common factor of 21 and 3. You're doing it in decimals. The greatest common factor of 21 and 3. Is 3. They have a 3 in common. So I take out a 3. Do they have a letter in common? D. They have, both of them have a D, so take out D. So what do you have left over? 21 divided by 3 is 7. If I took out a D, what do I have left over? C. Negative 3 divided by 3. Negative 1. And if I took out a D, then there's no more D's left over. Okay? Number 11. What do both of these have in common? An A, right? They both have an A in common, so take it out. No numbers. Don't worry about the numbers, right? So if I took out an A from this one, what do I have left over? B. And if I took out an A from this one, what do I have left over? I took it out. Negative 1, because don't forget the symbol, okay? Problem 15. What do they have in common? They both have a y? Number 13, they both do not have a y. And they both do not have an x, right? And if you put 5 and 13 in the calculator, there is no greatest common factor. So if nothing can be taken out, what is that called? Prime. Okay, if nothing can be taken out, it's a prime. Oh, 13, my bad, 13. Okay, I'm going to do 2 more. Problem 14. Let's get the greatest common factor of 18 and 24 in the calculator in decimals. And let's figure out how many A's they have in common, how many B's they have in common, and how many C's they have in common. So I need you to pause the video real quick. Try to work out problem 14 before I show you how to do it. Okay, so when you put this in the calculator, you got the greatest common factor of 6. Okay, that means they both can be divided by 6. Now, what letters do they have in common? Both of these have at least one A. So I'm going to take out one A. Both of these have a B. So I'm going to take out a B. And both of these have at least 2 C's, right? Because there's 2 here and 3 here. So I can take out 2 of them. So when I start dividing, 18 divided by 6 is what? 3. If I took out an A from here, how many A's do I have left over? 1. If I took out a B, do I have anything left over? No. And if I took out 2 C's, do I have any C's left over? No. So this stays like that. Negative 48 divided by 6. Negative 8. If I take out an A, do I have any A's left over? Here's an A. I took it out. There's no A's left over. I have a B. I took out one B. I don't have any B's left over. I have 3 C's, and I took out 2 C's. What do I have left over? 1 C. It's like you're taking them out, and then you're telling me how many are left. That's what you're doing. Okay? And then the last one, problem 16. I want you to try it really quickly before I give you the answer. Put 9, 18, 24 in decimals and figure out the greatest common factor. And then tell me what kind of variables they all have in common. Okay, so when you put GCF 9, 18, 24 in the calculator. 9, 18, 24. They have a 3 in common. So we're going to divide everything by 3. Okay? How many R's do they have in common? Like, what is the least amount of R's that this thing has? 1. It at least has 1. Do all of them have an S? No, this one doesn't have an S, so I cannot take out an S if there is none there. Okay? So it's just 3 R's. So divide 9 by 3. 3. Take out from 8 R's, take 1 out. You have 7 left over. Okay? Negative 18 divided by 3. Negative 6. If I have 2 R's and I took 1 out, how many do I have left over? 1. I have an S and I didn't take any S's out. Then I have an S left, right? What's negative 24 divided by 3? Negative 24 divided by 3. Negative 8. Here's an R. I took 1 out. Do I have any left over? No. Here's 2 S's. I didn't take any out. Then I have 2 S's left over. Okay? That's how I want you to do the rest of this paper. And you're going to put your answers in Schoology. There's going to be an assignment in Schoology where you're going to put all your answers, but I need you to do it on this paper first. Go ahead and finish.